Okay, and Dr. Jaisalan just stepped out, so I'm filling in as it's very similar to what we did in the Kaplan-Meier at this point. So let me just start from the beginning. We go to the file, open file. Then there is a file called Cox proportional hazard R shiny, and then you double click, it should open, and Control A, and then you run the app. It should take you to the window where you browse the data. The data is again same Anderson at this point. Now select the survival time, which will be the time variable. And the status variable would be 0 and 1. And at the later stage, we will be looking at computing risk when Shrikant is presenting about it. During the time, the status variable will be 0, 1, and 2. Just for information, then you select the covariate. So when it comes to Cox proportional hazard model, not like a Kaplan-Meier, where you need to have a covariate, which is your treatment group, which here is Rx. And then you need to also have the grouping variable for the survival plot, which is the same Rx. Now, one feature that you can see here in the Cox proportional hazard model is you can add covariates to it. Like if you want to adjust for sex, you want to adjust for log of WBC, then you can keep adding on it. So first, let's run it just with the treatment group. What's that? Sure. Okay.
So can everybody get to this?
Okay. Okay. Oh, you mean the data? Okay.
Oh, because the other shiny is with Excel, not with SPSS.
This is shiny one. It's working for you? It's okay. Oh, okay. No worries. Is it working? Is it working? Yeah? Okay. Great. No? Okay. It's working for you? Is it working for you? No?
Something happened. Suddenly said some errors. This package is not there. So why? So I put run the app. And suddenly says yes. So I and restart it. Because
weekend I had the same issue. Something is not working.
So, my God.
Yours is not even. Is it good? Yeah. No. That's what next step is. Okay. So if you have the time variable status and covariate is Rx,
Say some factor is missing. Maybe it was a disturbing factor for the reason. I consider that maybe
Open the code which is inside the deployment where and Cox model. Okay, don't open the Cox folder. The deployment where and Cox model, the code is there.
so there is a folder called Kaplan-Meier and Cox model. In when you go inside, there is a shiny app called Cox. There is a separate folder called Cox model time dependent. That's a different one. So please do not open that. It has a separate feature to apply for the time dependent covariate. Okay. Yes. So if you go to file, open, you should see a folder called Kaplan-Meier and Cox model. When you double click, there is Cox proportional hazard. Yep. So when you run this, you should be able to get into this browser window where you can put in the time, the status. The covariate at this point is just the treatment group, which is Rx. And then the selecting grouping variable for the survival plot is same Rx. And as I mentioned, you can also add on more adjusting factors like log, WBC, or sex, any other variable that you might have. And now we can see the interpretation of it. For now, I'm just going to leave it at this point with just the treatment group. And you click on Run Cox model. The results would have been generated in different tabs that you can see at the top. Cox model summary, pH assumption, survival curves, and model statistics. So when you click on the Cox model summary, you might notice a lot of numbers over there. As you have observed in the Kaplan-Meier, we have 42 observations. We have total of 30 events. And now you can see the actual coefficient, the beta coefficient, the exponential of the coefficient, which is the hazard rate ratio that Shrikant was talking about. And you can see the same here, right? And then you can see the output with the confidence limit and the p-value, which is highly significant. Would anyone like to interpret the hazard ratio? Yes, so it's modeling for the group 1, which is your treatment group. So that means you are comparing between the groups. It's a higher risk. It's 4.8 times higher risk of having an event compared to the placebo. And then, as Shrikant was just talking about the pH assumption, you can also see here the p-value, which is generated. And again, you can see the residual plot. Currently, based on what we look at it, let's go one by one. If you look at the survival plot here, it's almost parallel. So we can confidently say it doesn't, it met the pH assumption. It's not violating anything. This is the first one. And then you can go to the pH assumption test, which is done using here. If it's significant, it'll be less than 0.05. It is not. And I don't think the Shiny app is doing the time dependent or time varying covariate. Is another test, as Shrikant was mentioning. It was not done in this app. Probably that can be an added one to this app for you. But as Shrikant was mentioning, it's very important that it's all visually and also testing it. It's in a totality, you need to make a decision whether it violates the pH assumption or not. It is not just a single number that tells you, oh, everything is done. Now we need to go for RMST or anything like that. It need to be a totality of information. Yes. Yes. So here, so the way the app right now is set up is we are creating a grouping variable for Rx, which is a treatment group, which is 1 or 0. And also this covariate is the main one. The model is, as you know, we need to have a survival time by the event is equal to the treatment group. We are having the beta coefficient for the treatment. So right now, treatment is what we are looking at it. Now, if I just add an adjusting factor, you want to adjust for sex, you want to adjust for log WBC. As you all know, in clinical trial, we don't need to adjust for different factors because randomization should technically take care of all the balance on it. Still, if there may be any factors that you would like to adjust for or any stratified variables, then let's add this, and you will see in the model 2 hazard ratios. Now, before that, it was 4 point something. Now it's 5.331. Now it's a hazard ratio adjusted for sex. Now, in a Cox model or in a clinical trial setting, we do not interpret the sex variable. We do not say 1.34. We do not write any interpretation around the adjusted factor. It's an adjusted factor hazard ratio on the treatment is what we are trying to interpret at this point. And now the same pH assumption after adjusting factor. What is it? Is it meeting or not? And again, we don't interpret the adjusting factor and we don't say whether at this point. So, and I think in the earlier discussion, we also had something to talk about how good the model is. Sometimes it won't be 100% right. Like R square, for example, when you run a model in a regression analysis, you want to look for how good the quality of the model is. Similar to that, we can also have some model statistics, a C index and log likelihood, just to see how good the model is. Is it interpretable? Is it okay? 0.7 is a very good number to actually say the model is okay. But again, we have a better C index in a lot of ways. But these numbers are all very highly not interpretable in the sense it's not highly used in any journals. They don't talk about C index. They don't talk about AIC and other stuff. But when you submit for a journal, they will come back for a review. At that point, they will ask you whether have you tested for proportional assumption. Yes. And then you need to start giving all this plots the p-values, the residual plots to tell them that yes, we have checked it. It didn't violate the assumption.
You don't have to, all kinds of stuff.
No, we don't. That's what I was just telling. We might need to do that, and also the time covariate. Yes. Anything above 0.7 in a normal clinical trial that we have seen, it's good enough. We have seen in an average of 0.7 because always we try our best to see if a model can predict anything more than 0.8 in R square, as you might know, anything above 0.8 or 80% is good. Similar to the same concept, we can also say that. But we run a multi-center clinical trial. We are going to expect a variance between the site, and a lot of things are adjusting factor. Even though we do a randomization by site, we end up not capturing all the information, but 0.7, 0.8 is good. Yes. I think this is
But the confidence interval.
oh, this one you mean? This one or this one you're talking? You mean the top part?
Curve.
Curves at the bottom.
Oh, the curves.
There are some
So
green
here,
dots.
which is sex, how do you figure that out from the data that you have put in? Like, which is sex, which one is treatment?
Oh, I removed it, but this is only for the treatment. The curve, survival curve that you are plotting here is only for the treatment, but is adjusted for sex. When if, for example, give me a second.
Treatment versus treatment.
Yes.
So in these two, which one, how do you figure out which one is your placebo? Oh, that is, one is with treatment and one is without. But even in this, how do you figure out which one is?
I think we need some work on this plot is what I feel. Compared to the Kaplan-Meier that we looked at, it was more clean and clear. Here I feel I think the coloring
No,
options.
just how to interpret what it's giving you. That's what I want.
Yeah, you should have some blue legend.
What is the pink? What is orange? Which is pink? That legend is not.
Most likely the pink is the treatment group. It's the same Anderson one. Whatever you have seen in the Kaplan-Meier is exactly the same. It is nothing different than what we are seeing. What's that? Oh, it's stretched out, and also the color option. There are some censoring that you can see in them there, but the different colors over there too. Yeah. The red is a treatment, and yeah, it's exact. Yeah. Yes. No.
You don't see the line.
That need to be changed for sure. Okay. Over to you, Shikan.